Hello. How you guys doing? Welcome, welcome, welcome. So, yeah. I got a turbo file a while back. I'm gonna figure out how it works.
Hacker man. He's the most powerful hacker of all time.
Joe Micah, thank you for the 66 months. Holy shit. Thank you, thank you.
Add another 6 and it's evil, or Emperor Nero, was originally referred to.
Evil. How you guys doing? Etterfaust, Bridgewater, welcome, welcome. So yeah, the other day I actually finally got around to fixing the situation with the turbo file about a week or so ago. That situation being the ungodly amount of corrosion in the battery compartment. Thankfully, it was all contained to the battery contacts and nothing else. Wasn't on the plastic. So I just removed the battery contacts and added a battery pack. It's fucking wire sticking out of the fucking thing. It'll work probably. I don't know. But yeah. So we're gonna work on figuring out how this works. Work didn't take everything out of me this week, thankfully. Yeah, so we're gonna figure out how this works. I've already looked at a little bit of it, and I already hate it. I already hate how you have to communicate with this thing if it's how I think it is. If it works the way I think it works, it's going to be ungodly slow, and incredibly frustrating and annoying to actually do anything real with. So it's easy to fix. Well, yeah. So yeah, I unsoldered the contacts, and then the little metal bit on the bottom that was self-contained with a spring on one end, right? I just got some pliers and ripped that out, threw that away. Like, all right, we're done. And I soldered on the battery pack onto the old contacts, so the old board pads, and it's good to go. So now it's down to writing software that can both read and write this. So because it is battery backed and hasn't had a battery in it forever, there's no valid data on there. So while I have a routine that I think is supposed to be able to read shit, I don't have anything that can write anything, right? So what we're going to start with today is writing to this thing and see if we can verify reading that data back. Yeah. So let me actually get this plugged in. Like so, and I've already got this turned on, right? Yeah, okay. So let me show you what I have already, but like I said, nothing's written, so it's not going to read anything valid, right? But the idea is you press A, it reads whatever address it's currently at, because it starts always at 0. Or rather, you have to reset it to start at the beginning, and it has an internal like address counter, I guess. And every time you read enough bits, well, I'll get to that, it moves to the next address. So here I have it reading 16 bytes, I think. So I think the only thing that is certainly correct here is that first byte is always supposed to be 0. Like you can't actually write to that byte, I don't think. I will be verifying that. But so if I hit A again, it should move to the next address and read what's there. But I don't know if that actually updates and is correct, right? Hitting B should reset it back to the beginning and reread it and all that kind of shit. But again, jank as fuck code. I need to fix it. But first, I need to figure out how to write to the damn thing, right? Oh, and write protect is on. Let's turn that off. Okay, on the top there. There's a red light on the top of the thing, so that means it's at least getting power. So it's doing something. I don't know. Yeah. So, that's not the one I wanted. No, it's, turbo. Okay. We're just gonna abort all that. No, quit. Okay. Sort by, sort by, sort by, sort by, sort by, sort by. Why is everything reversed? How did I fuck that up? I said quit, damn it. Okay. So this is my key test ROM that I've been fooling around with, adding to whatever. And as you saw on there, it's one of the menu items. So, next week I only have 1 day of work. What the fuck? Got a company summit, so I got a hotel room for almost a week with some time not doing anything. Nice. Nice. So you see me in chat on Sunday. I'll be from a hotel room. All right. So the way that I think this stupid thing works is, well, so it's plugged into the expansion, obviously. So it goes to the controller ports, right? But it's fucking 1 bit at a time, not byte or like nibble, half a byte. It's 1 fucking bit at a time. And once you read 8 bits, it auto advances to the next byte, right? So this shit takes absolutely forever, right? Because not only is it like 1 bit at a time, you gotta fucking strobe it for the next bit, right? Maybe? I don't know. So, reading data, sure. To read a bit, read the old data from, read it and write it back unchanged. Yeah. So read the data, right? So you read that address and shift it, whatever. So you get the actual data bit. No, data bit, this guy here, right? And then you need to clock it to advance it, right? But the clock has a data output on it, right? So if the write protect isn't set and you're not careful, it'll just erase everything as you read it. So you need to write it back as you read it. So I already hate this format. I don't think you missed anything important. See, I already hate how this works, how I think it works. But in theory, writing the data shouldn't be that bad. Writing it is just, two writes per 2 writes per bit. Okay, so let's start with some stuff to actually write. Text A, text B, test data, right? No, we're gonna use bytes. We're not. Yeah, we'll use ASCII Z with 0, 1, 2, 3, 3, 4, 5. 6, 7, 8. Right, 8 bytes, right? So this should be 30 through 38 ASCII, right? So that's what we should see in the printout eventually. So, okay, 9 bytes if it matters. That is true. That is 9 bytes. We're 0 to 7, 37. Good catch, thank you. Okay, so write test. We are just going to write this direct. We're going to reference this directly. We're not going to bother with indirection right now. We will maybe eventually, but yeah. Okay, so first, we need to initialize that to 0, right? Which is this right here. Reset the address to 0. Um, yeah, 0 then 1. Okay. I wonder if that'll actually reset, like overwrite whatever's at the current address it's at. That'd be weird. Yeah, it's for library. Yeah. There's things that I'll do maybe later, right? But we need to figure out how it fucking works first. All right, load. 0. Store that into, it's 4016 for these, right? Yeah, 4016. Store that into 4016. Load up 2. Store it there. So this is reset address. And then I need to get past the first byte. So that means load X8 and loop of store A. No, hang on. Load Y. 6 and 2. Clock line. Wait. I don't want to reset that, do I? Cuz 2 resets the address, doesn't it? No, that'll keep it high though. Keeping it high. All right, that keeps it high. Okay. So write 6 to strobe it high or set it high. Write 2 to write it okay. So this is going to be 0 6. Load A 0 2. Store Y. Yeah. 204. Fuck. 4016. 4016. Store A. Decrement X. Branch not equal. Backwards. Okay. Get past the first byte. Universe this week. Ooh. Well, I had to watch it. I heard some guy screaming through half of Israel's performance. What? Oh my god. Isn't Look Mom No Computer in Eurovision this time around? That's the only act I care about. The only one. Okay, so and don't expect he'll do. Yeah, I don't. Sure, but I mean, again, he's the only act I care about. So I mean, it's Eurovision. I'm not in Europe, so I don't really care about really anything else. I don't. You know, I'm just glad my boy is participating. Honestly, I'm just happy he's there. I have been following him for years, and to see that he's got a big stage like that, yeah. Why is there an American in the contest? What? How? Fucking what? Is he like? Is he participating like with another country, or does the U.S. somehow have a spot there? Because we shouldn't. If it's Eurovision, what the fuck? All right. So I'm gonna want a routine that like writes a byte. I'll write a byte. This will take in A, and it will write that byte to whatever address it's currently at. From Utah, okay. Their mom is French, so she's singing for French. France in French. Ah, okay. Say, I knew there was a loophole in there somewhere. All right, so for this, loop. We need to store A into temp something or other. Because I need to do a bunch of shifting with that, as well as ORing. Where's my temp X is work start there. Okay. Load X 8. Back in the day, Swissler had Celine Dion sing for them. Decrement X, branch not equal, loop. Okay. All right. So we're going to rotate temp X, and then load a 0, 0. I can't rotate onto A. God damn it. Son of a bitch. So I want to get like one bit off of a time at a time. But I need that like in A. I mean, I guess I could just like branch carry clear like that, right? So carrier's not clear, so we're loading up fucking we'll do percent here. Oh, data output that's just 0. Sorry, 1. Okay. So no. Load up 1. Otherwise we're gonna load up 0. There's that. Okay. Then we're gonna OR that. No. We're gonna push that. Then OR it. Can't I? Oh, maybe I can. All right, never mind. All right, so we'll do that. Push it because we need to save it because we need to do it twice. OR it with 6 0 6. Store that into 40 16. Pull it. OR it with 2. 40 16. That should work, right? Most crazy doesn't matter where you're from as long as you represent one of the European broadcasting services. Yeah. Okay, so this clobbers X, so which means we can use Y. So load Y 0. Loop. Load A. The fuck did I call it? Test data at Y. Branch equal done. Otherwise, write JSR write byte. Increment Y. Jump. Loop. Right? Maybe? Probably. Instead of push pull, you could do and 3. Huh? Trying to be more supposed to. It's fine. It's fine. Okay, so that should write all that. And then after that, I would want to read it back essentially. Which I don't know, ask a read byte. Read data, no. Reset address, and I think I want to do a read add. Reset address and read data. JSR reset adder. And then a JSR read data. Okay. Yeah. And to trigger that, yoink, paste, button, start. JSR to write test. Okay. Start. I see 0A everywhere. I don't think I'm doing something right. Let's try in the emulator. Turbo file. Start. Start. No. Okay. So I am not doing something right, and I noticed. I know the shit's all jank. That A was after I tried the right. So if I over here and I switch the bank to the second bank and just hit A to read, F. Reset. Go back to bank 1. I go back to bank 2. Reset. And then hit start. Wait, was that on the reset? Wait a minute. Bank 3. Reset. A. Reset. Okay. Start. Turns it into A. Back to bank 1. Read an A. Yeah, it's apparently written something. Not exactly what I wanted or expected. And the emulator also isn't doing what I expect. So I clearly, very clearly have something wrong. No thanks unless you're reading it wrong. So I'm doing something wrong. So let's check over my read code here real quick. And make sure that that isn't incorrect. So that read code, read data, starts here. Read loop at whatever current address we're at. Oh, yep. Scene. Yep, this one here. But chunks, yeah, I don't know. What is this? I think this is just like, okay, yeah. So this is just the buffer data. Okay, and let me start by making sure that I have the buffer data correct. How about that? So, nope, not that. I want this button. Find read data in here. Buffer data increment JSR. Read byte. Store that there. Data ASCII. All right, so we're just gonna breakpoint there. Read. Okay. Data to ASCII. I'm going to modify buffer data. Reviewer. Okay. So 30, 31, 32, 33, 34, 35, 36, 37. Okay. So this should no. That's not how I do that, because I do some bullshit with the fucking no. 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 So this is going to be 0, 1, 2, 3, 4, 5, 6, 7. Over there. Okay, so it's got two 32 bytes somewhere in here. I think starting there. 18, 17, 16. Starts there, actually. Hang on. Wait a minute. Hang on. Let me zero all this out. Okay. So starting here. 1, 2, 3, 4, 5, 6, 7. Okay. And then the first 16, or the first 16 is going to be blank. Second 16 is the first 16 bytes that it's read. I think. I don't know. I'll find out. Fuck. I'm confusing the shit out of myself. All right. This does some weird shit with... Well, not weird shit, but this does some bullshit with... Buffer data. Oh, my God. No, I was right before. Okay. I wrote this fucking last week. 7. Because it takes right, because it takes each byte, makes it 2 bytes essentially. Yeah, so we're gonna step back by 1. There it goes. Oh, all this needs to be zeros again. Doesn't need to be. I'm gonna make it anyway. Okay. All right. Oh, God damn it! I did it again. One, and it with F. Put that in X. That, store that there. 30. Okay. Load that up again, and the bottom bit of it, 31. Store it there. Okay, this looks like it works. Where's my screen? Okay, that does work. All right, so the stuff in the buffer does actually display as we expect it to. Good. All right. Okay, bye. How you doing? Could be NVIDIA. So, could NVIDIA be so nice and give Linux the new drivers already? But NVIDIA is a piece of shit. They are bastards. They're absolute bastards. They're not interested in anybody but themselves. No. Okay. So, data to ASCII works. So, but we're putting in data, apparently. 85 minutes on Horizon season. Forza Horizon 6. 4 crashes. Ooh. So AMD basically since their move to AIBS. Yeah. Somehow they got the HDMI 2.1 spec coming to Linux though. Somehow. All right. So this address pointer here, I believe, is just what I'm displaying. I think. No, wait, what the fuck? Wait for NMI draw text. I also wrote this macro. 2105, so I don't have to do this bullshit like that. Okay. Another news got a massive milestone done. Ooh, it was correctly parsed Smalltalk 80 images into my memory model. And all values for the well-known pointers look good. Ooh, nice. Nice. You know I didn't double check here. I'm using the Mahjong controller add-on here. Turbo file. Okay. Reload ROM. Okay, that's even showing A. So something is very wrong. All right. Something I've got something very, very wrong with how I thought this worked. Okay. Only one minor beginning little Indian screw up. Oh. All right. Yeah, I said 5 first, then A. So something is definitely wrong. So this read byte. Okay. Reset address to 0. Let's do that. Okay, so read data. Where is that? Just asking. Or no. Up here, it reset address 4016 0 and 2. So that should reset it to the start. Does that. Address to ASCII. Does this wait for NMI to write shit to the thing? No, but it should. Or rather, do that. Wait for NMI. Because buffer stuff kind of like gets clobbered during a bunch of that. I have a feeling whatever is causing that graphical glitch is somewhat related. Yeah. Read two 16-bit values into the wrong variables. The length became the last index, and the last index the length. Compiler was not a happy camper, only overshooting the array index by a casual 3 million. Oh, it's fine. Okay, so read byte. Load X to 8, so that's 8 bits, right? So because it is to read a bit and write it back unchanged. Yeah, the address automatically increments after 8 bits or clocks. To read-write the given address, the program must reset the address to 0 and seek to the desired address by performing dummy reads. Fuck you. I hate that. I don't have to reset the every single fucking time, do I? I hope not, because that'd be stupid. Yeah. Read and with 4. And with 4. Shift it by 2. Save it. Put it in carry. Rotate it back on X. That sounds logical, right? Load Y, the saved value. Or with 6. Store it. Load Y again. Or with 2. Store it. That should clock it. Right? Decrement X for the next byte. Right? Like, I'm not going crazy here. Like, that seems logical, right? Given what... Right? Where's a game that uses this shit? Dungeon Kid, 1990. Do I have that? I do. I gotta find it in here. I have to fucking find it. Add a breakpoint for writes to 4016. And at a breakpoint for a read 4017. Oh, that's gonna break all the goddamn time, isn't it? Yep. Okay, so there's the controller bit. Is it part of the edit stuff? Oh god, what does this say? When you run that routine, does it hit NMI before it's done? That'd be a problem, wouldn't it? Maybe. Let's go back to that real quick. Actually, hang on. Recent key test. Turbo file. And now, animi. No, animi. There it is. Put a breakpoint on that. Pop, 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 pop. A to read. Oh, so we just started. Yeah, okay. And tile map. It's an address to ASCII and read data. Well, no, wait, what the fuck? Breakpoint there instead. Let's do this a little differently. Just a little bit differently. Read data. Oh, I need to unhit A. Hit it again. Nitrix 8 welcome. Okay, now I can turn on an MI as well as the RTS. Yep. Mm-hmm. Now, was I in a wait loop? I was in a wait loop. Okay. Right, because it waits to get to that spot. Tiles, rights. Waits for the next enemy. Oh my god. Oh, that's why that happens, because I don't fucking... Okay. Yeah, that's that. All right, that makes sense why that's happening. Okay. Jump out of that. And that draw text. So a few enemies happen at a time, or not at a time, but in each of those, because I'm waiting for them specifically. But it's not during not during the read at the very least. Let me see if I can fix that visual glitch for this. Draw text. Load up 0. Store that into 2005. It's 2005, right? Where's my this one? Yeah. Yeah, okay, it is 5. All right. No, actually. All right, yeah, so that fixed the visual glitch anyway. Wrote 5, hit B, reset. And it just resets it to fucking A. Save, store, yeah. Load that up, put it there, increment 1, compare to 16, loop. Like, okay, oh, 1. Zero 2. It is coming back as A. 03. Okay. I don't think so. Where would this shit be saved, actually? Hang on. So let me exit that. Because that, in theory, should be saved somewhere from Messin, right? Because it's a save file, essentially. Config messin. The fuck is neck vibes? Yes, right here. Okay. Okay, if I, do that. It's putting A there. Why? I'm hex plus hex editor. I don't think any of these are any good. All right, well, but this might allow me to do something here. Okay, so 0, 0, 0, 1, no, 0, 1. Oh my God, what the fuck? A, B, C, D, E, F, G. Let's make them capital. I'm gonna save that. That's still the same size, right? What the fuck is this? Huh? Fuck. Oh my God. No. Oh my God. Okay, that's 16 across. A, B, C, D, E, F, G. It did not. Okay. Save that. I want to keep it the same size. The Tetris turbo file? Sure, just keep. Why the fuck does Tetris have a turbo file? What? Okay. We got something there. It's fine. Open this up. Turbo file. Read. No? What? Hold up. What the fuck? Wait. What the f... I don't have it open. Huh? Did the save file get modified or does it still contain the ASCII? Still contains the ASCII. From a minute ago. Did I change something else with that read? That means the read is only partially working. Get it at least at the bottom 3 bits. Oh, wait, hang on. Yeah, okay, yeah. So let me change 1 byte of that. Key test. I'm looking for the wrong fucking file. Five A. Okay. Is it only... let's go ahead and reset. Turbo file, read. Okay. Load that, store that there, clear it out. All right, loop, read a byte. This one's actually going to be the very first one, I think. Right. Yeah, so this one's going to be 0. Right, I expect this one to be 0. Three, 2, 1. Okay. That one I expect to be 0. That's fine. Read byte. Load 8. And it with 4, 41. What the fuck is A? Was it 5A? Is it most significant bit first or least significant bit first? I don't fucking know. I may have actually done it backwards for the read order, but that shouldn't matter with the whole, like, only getting half the thing. Shouldn't, in theory, right? So, okay, if we're reading it backwards, the next one would be a 0, right? Maybe? And it with 4. Why did that clobber it? $45. And it with 4. That one's 1. Okay, no, never mind. All right. Okay. Maybe I am rotating on correctly. This one would be 0. Rotate on that there. Okay, yep. No, there's 0. That doesn't seem right. Hold up. I have 5A here. Load it. Store it. Huh? Five A versus all 5A. Well. Buffer data plus 1, address A4. Wait a minute. Wait a minute. Wait a fucking minute. I have it there. Okay, data to ASCII. Yeah, what the fuck's going on here then? Okay, load Y0. Buffer data Y. A3. Right there. Load it up. 0 is going to be nothing. Fair, fine. Yeah, okay. Yep. 5A. Shift it 4 times to get the 5. I shifted the wrong fucking direction! Ugh. Left, right, left, right, left, right, left, right. Oh, look! I've got shit kind of almost working now. Oh my god! Who knew? Not start. Send. Swear to God, if that was it. A to read. B to reset. Start. A to read. No. Okay. Okay. So let's go back here. I disabled the thing. Okay. Make. Yeah, I disabled it. Yep. Reload. That's not the emulator. God damn. A. A to read. Stop it. Go away. A to read. Okay. B to reset. Start. Start. Okay. Okay. So if I close out of this and I have a look at that file again. Over here. And then that. What? Yeah, did it not fucking save? The right time is correct. Did it just not fucking save? What? Turbo file. Read. Reset. Start. Read. Turbo file. Read. Reset. Start. Does fuck all. Write protect is off. Magic show. Yeah, right. I don't suppose this guy supports fucking this thing, does it? Paddle, shadow, gun, keyboard, mahjong, buzzers, family trainer, tablet, really? Typewriter. No. Okay, so that one doesn't support that. Okay. But also, this isn't advancing like I would expect it to advance. Does my controller read code clear those bits? Fuck. Fuck, it does. Oh my God. Oh my God. God damn it. Fuck. Okay. No. Okay. So, oh, Jesus. So I need to. Before actually reading the data, I need to reset every fucking time. And. Oh. Advance to where I need to go. Shit. God damn it. Give me this back. Put it there. Oh, I hate that. All right. So we're on address pointer 3. We're going to copy that to another address pointer and then basically just decrement that. Yeah. How many addresses are in this fucker? More than 256, isn't it? More than a byte. $8K each. $8K each bank. Oh, I hate that so much. All right, yeah. So, load up address pointer 3 plus 0. Store that address pointer plus 0 plus 1 plus 1. Okay. Oh, fuck. We're just gonna loop through read byte, and just discard what it has. Okay, so we are going to. Oh God, how are we gonna do this? Load up. Address pointer 0 plus 0. Address pointer plus 0. Branch not equal. Plus 1, branch equal to done. Dummy done. Otherwise, we are going to JSR read byte, set carry, load a, that, subtract carry 1, store it. Right? Is that right? If the low byte's not 0, don't bother checking the high byte. If the high byte is not 0, go onwards. Right? Sure. I don't know. This probably doesn't work. We're gonna try anyway. All right. So reset, reload. Control Shift, reload. Yeah. Okay. Okay. These are going so long, I think, that fucking... Oh, no. That it's... Animize happening and clobbering shit, I guess. Right? Maybe? I don't fucking know. Alright. Debugger. Give me debugger. Read data. Get over here. Alright. We're gonna start right there. Okay. Read some data. Okay. So, we are way down at the bottom there. Okay. This dummy byte is going to get a highlight. And we're gonna go down there. Oh, fuck. $125,000 cycles. 125,000 cycles. Oh no. Does NMI use that pointer? I don't know. Okay, read byte. What does this use? This uses temp X and Y. Okay. NMI. NMI loop pointer, I think just goes to NMI done. Prepare NMI pointer. Load up buffer index. What is buffer index? FF! Branch minus to empty. Okay. Branch minus to empty. Empty goes to that. Okay. Okay. Okay, let's hang on. Let's hang on. Hang on. Hang on. Okay. Hang on. Turbo file. Okay. Pop. NMI. Yeah, that's fine. Pop. Okay, barely anything. Sure. Well, no, not barely anything. Actually nothing. Because it didn't need to progress anywhere. Right. So now the next one, this one needs to actually progress. Turn it into my. Oh. Oh no. Oh no. Okay. We need to unroll that, I think, a little bit. Yeah. Repeat 8 times. Get rid of that. Get rid of those. And repeat. That's step 1. Step 2 might be moving that out of a function. And inlining it. I don't know. Okay, reload that. Stop that. Turbo file. Yep, get out of that. Okay. Turn on NMI. Better. Still atrocious, but better. Yeah, it could still be, yeah. Sure. But that is a single byte read. No, that's... Wait. No. Yes, each of those is a single byte. Okay, yeah. Each of those is 1 byte read. Okay, not as bad as I thought. I thought that was a one byte for that whole, well, 1 byte for the whole chunk. That's all 16. Yeah, it's hex 10 bytes total. Yeah, not that bad. Okay. Next. Worse. Next. Even worse. Oh my god. Okay, so we're doing a lot of shit here that we need to optimize the fuck out of this right here. So what were you saying about the ands? See, I need to store it. Rotate. I'll say rotate it there. And it with 1, 2, 3, 4, 1, 2, 3, 4, like that, right? That's gonna be the same number of cycles, though, isn't it? Appendices. Thank you. Oh God, can you just give me the fucking two cycles? No. 3 cycles. Moving the aura 20. Aura 2. Right, okay, because this sets that bit anyway. We're unsetting that bit. That's what that is. Okay, yeah. Right. So that removes the OR, which is going to be another 2 cycles, right? And load A 0 page is 3. So we're taking 5 cycles and making it 2? Right? Is that what's happening? And it's unrolled. All right, so read. Sure, yeah. Read. $5,000 cycles. Same as Aura, but it saves LDA. Yeah. It's probably better. It's not as lined up anymore. reordering a few things. Let's get rid of those. Like reordering what? If you move the LSR, rotate temp X to the bottom, you can skip using temp Y. That's true. Don't need to do that. That's very true. So it was like 5-ish, 5,000-ish cycles, right? That last time. 4,000. Okay, we cut off a good chunk. All right, cut off 1,000 cycles roughly. Okay, that's better. Still gonna be god fucking awful. I do still have an error or an issue with when it hits more than a frame. Which is going to happen soon. Not yet. Okay. Not yet. Reading 50 bytes, taking 2,600 cycles. Turn that off. Whoa, 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 whoa. No. No. Actually, what? Three, 4, 5. And then somehow in here it fucks up. Okay, there's... TAX, TXA? For No, I don't think so. I don't do any of that. And then this hits NMI, doesn't it? No. Read byte. Read byte. Is that unrolled loop? TS, okay. Store that there. Increment. What are we at? X of 6. Y. 3, 4, 5, 6, 7. It's gonna hit like right there. Okay. All right. So Y is at 7. I don't. Oh no. Okay. I push A. Store X. Store Y. I back them up. All right. Sprite stuff. I don't think I really need to do. And am I done? Okay. Loop pointer. That's done to loop pointer. Buffer index. Clear that out. Load of zeros. This is scroll. Okay. It does shit with carry, doesn't it? Well... God damn, it does shit with carry. RTI should be restoring carry? That's, yeah. All right. Because, yeah, it stores the status bits, doesn't it? The flags. What is our current scroll at, though? Debug. Tile map. 0, okay. Oh, that's going to go up to hex 10, right? Right. A, B, C, D, E, F. I don't know why I thought I was going to go to 8. Swillbup, how you doing? Are we emulating 6502 in Go? Not this time. I use Go for a lot of stuff. For current projects, it's more of tools to help with reverse engineering. Reversing and figuring stuff out and utilities and the like. While I'm not working on it tonight, thank you for the follow, appreciate that. I have a disassembler that I wrote in Go that I'm using to generate this stuff. Let me turn off that. So this is study box script. So for this thing, this is a study box. Tape drive thing for the Famicom that's got like English lessons and shit on it, right? It's an educational device, and it uses a domain-specific scripting language that is interpreted in assembly. So I've got a disassembler to disassemble that script, so we can figure out how it works and all that. I still have a ways to go on that. A lot of what I'm doing with this is right now is very tedious housekeeping, I guess, because there's a lot to go through with that. But tonight I'm figuring out the turbo file. Jojo, how you doing? Committed a crime. What'd you do? What did you do? Yeah, we have made a 6502 emulator in Go though, but that's not what we're doing right now. Yeah, right now I'm trying to figure out why the hell it's vomiting all over the screen. Because it shouldn't be. I don't know why it's writing that shit. All right. And there's one more. No, that was the last one. Okay. Data to ASCII. Okay, what is in my buffer data? View my reviewer. Bugger all. Starting at 0. Why does it start at 0 there? 0 and the 30. What the oh, whatever. Sake won't, right? You want to, oh no, you want to warm sake and force it to 5 seconds in the no! Microwaves? Oh my god, how dare you? If you're not mad, it's not hard enough. Yeah. I hate this thing already, right? It's neat, it's nifty. So it's basically like a memory card for the Famicom, right? Let me see if I can find a picture of it. ASCII turbo file. So there's 2 versions of this stupid thing. That is for the Super Nintendo. No, okay, so this is the first version. I have one of these coming in the mail. The one that I have is there. It is looks like that. That's a terrible picture. Okay. Is there a better picture somewhere? I know there's a better picture. Hang on. On the auction that I won for this guy. Oh, here we go. Here's one. Oh, look. Yahoo Auctions. It's like a memory card thing for the Famicom. It plugs into the expansion port, and because it plugs into the expansion port, we got to read it like a fucking controller. And so normally when you like read or write data, it's in like a size of 8 bits, a byte, or 2 bytes, a word, right? 32 bits, right? Or if it's a fancy new system, 64 bits at a time, right? This, 1 goddamn bit at a time. 1. Not only that, I can't say, hey, this is the address I want to read from. Read that bit or read that byte. Instead, it's, all right, we're going to start at the start. Go back to the beginning. Go back there. We're at the beginning? Okay, I'm going to start reading now. So if you want an address that's 1,000 bytes away, you've got to read 1,000 bytes. Or 8,000 bits to get there before you can read the data you want to read. Oh, and you need to write it all back too, by the way, so you don't accidentally erase it while you're reading it. I hate this thing. 64 kilobit serial RAM, something like that. It's tape machine error. This is worse than tape machine. Okay? This thing frustrates me. All right. Is this fucking up? Like, what the hell is this doing? Give me event viewer. Okay. And actually, I'm gonna put this on the other screen, and I'm gonna put this guy over here so I can see that while I'm stepping to this. What? Do you also want to water my gift like a savage? Yeah. Tell me how 240 volt. Tell me how 240 volt. But not enough sockets for the kettle. Oh my god. I actually have one of those too. I have an electric kettle as well. I would not put sake in it, but you know. All right, well, but this part, like, works, right? I don't highlight reads, do I? I do. Where is it reading from? Reading from there, I think. I think it doesn't overwrite the read. Yeah, it's not overwriting the read. Okay. All right, so it's buffering it. Right, so it needs to figure out the ASCII, right? And then it needs to basically like rewrite the buffer to get it prepped for the NMI routine. So this is basically interlaced. Or no, this is I need to interlace these values, right? Because one is the high nibble, the other is the low nibble, right? And I need to interlace those into combined. So that's what this loop is. Yeah. What am I doing here? X and Y. Branch not equal. What the fuck? Compare Y. Why did it write a 0 there? What? I need to get rid of that. That ain't right. What the fuck? It's a 0 at the end, right? RTS. Wait for NMI. I should have hit that breakpoint because it's set. I don't think it wrote anything. Go away. I'm way the fuck up there. What? Was that... Wait. Was that for the... No, what? What was that for? Because, like... Nothing's highlighted here. Huh? Oh, no. Oh, no. What? Why? What? No. Wait for it. It shouldn't be. Where the fuck was that even? Not there, not there. Read data. Here. That. Pair that. Bit sleeping. I need to reset the sleeping, I think, at the beginning of that. I need to set it before I start checking for it. Yeah, let's set it first before that way. What the fuck? Yeah, okay. I think I had it backwards or something. I don't know. Okay, where is my debugger's literally right there. Is that over here? Turbo. 1. 4, 5. Okay. That would work as long as you never had a lag frame. But now you're getting here. But now I'm getting lag frames. Woo! Yeah, so the whole reason I have this like buffer going, like the way I have it set up and with an unrolled loop, was to get the keyboard displayed all in a single frame, right? The idea was not to have any lag frames, essentially. But now I kind of have to, because there's no way in hell I can read it that fast, right? We're gonna jump down to that. NMI happened before that. We're gonna jump out of that. All right. And then we're gonna jump out of that. Yeah. Where are we? Where's the scan line? Scan line 3. Okay, so we're way up top. All right. Data to ASCII. Ooh, that is disgusting. That's horrid. Not bad, but now we wait for NMI. And it actually waits for NMI. Huh. Who knew? Jump out of that. There we go. So now I can draw some text. Clear carry. Draw some text. Address to ASCII. NMI because I think that waits for it. Yes, because it buffers it. And this is using the fucking NMI draw for that. Yes. Yes. So that's expected. Draws that. So that did update that. Did just update that. Okay. There RTS. Okay. So now, if I turn those off, just start mashing. Okay, we're gonna see how long this takes. All right. Breakpoint on that RTS. 207,000 cycles. All right. Okay. Several drawing frames. Yeah, but still, that's a lot. Read. Oh. Okay. Okay, this is more what I'm expecting, I think, with uninitialized data. About 6 full frames. Yeah. Oh. It's becoming noticeable how long it's taking. Maybe I should like use a sprite for like reading, right? Put a sprite somewhere on screen, move it on screen for reading, and then move it off when it's done. It's taking like a full half a second now. Oh my god. So what I might want to do is I might want to add work RAM to this ROM and read oh fuck. How is that 8K? Yeah, read the full 8K into work RAM. There are ways to get rid of this delay. One for sure, and one I'm a bit curious about. You know? I mean, the delay is because it's taking forever to advance to the address. Modifying the controller read to keep the bit set when it is already set. Well, so I'm not hitting the controller code. I see what you're saying. No. I see what you're saying. Okay. So even when the controller code does hit, it doesn't reset to 0. Because every frame that's going right now, it's resetting that back to the beginning. And that would work more like I originally expected it to work. Or was originally trying to get it to work as. Yeah. Let me hit the bathroom real quick, and then I might have special control reading code specifically for the for this, so I don't pollute anything else with it. I'll be right back.
Hacker Man. He's the most powerful hacker of all time.
Celebrating 89 months of Chertoon streams. Kappa.
Okay. Bridgewater, thank you for 89 months. Holy shit, thank you. The possible one I'm curious about would let you keep existing controller code. I'm uncertain about it due to the wiki page being, but unclear about how that reset bit works. It suggests it clears on a 0 to 1 transition, in which case reset could be turning it high, then back low, and then reading while low. But if it actually resets while 0, that wouldn't work. Yeah, let me have new controller code. Turbo controllers, RTS. Read controller. Where the fuck is this? Oh, it's here actually. Okay. So it'd be this here. I have to change that. Or what? I'd have to make that high all the time, wouldn't I? Because it's low here. We'll yank that, put that there. Yoink, paste. Yoink, paste. What the fuck do I use? Do I use, I do use pressed, okay. Yoink, paste. Control +4, I don't care about that. Yoink, paste. Keeping it high all the time should work. Yeah. You know, let me just copy this entire thing because I don't feel like rewriting it properly. And then I just need to keep it high. So we're going to 1, 2, 3, 4 underscore 0, 0, 1. What? Fuck. Which one is it? Where's my window? Yes. Okay. Then yoink, paste. There, like that. Only those first lines, right? The 416 right? Could have just a custom replacement for that. Then jump to the existing controller code after that. Kind of. So, well, not easily. I'd have to have a new label in here and jump to that, and I don't feel like doing that right now. Okay, so let's comment out that the dummy read. For now, it's not the right character. The reset will do that. And we're gonna put that at the beginning of all of this as well. Oh, I did. Okay, reset address. All right. Let's see what happens. None of these are correct anymore. Oh shit, okay, that actually kind of works. All right, okay, all right, let's see if that works on hardware. It looks like it, okay. The right isn't doing what I thought it would do, though. Okay. Because the right should be doing that. It doesn't do that at all. And for that right, I do actually want to... Wait. That's not what's in there. It doesn't actually write anything. Okay, so the write routine now is broken. Cool. Well, it's not now broken. It just never fucking worked in the first place. Also, I'm using namespaces, so this is actually it is using the right code. Cause I'm using scopes rather. So I would have to do that for the global one now because I'm overriding the name, right? Because this stuff is in the global scope here, but all of the individual files are in their own scope. So I can do stuff like this, right? I did that the other day. Reset. Get past the first address. And then write a byte. I don't clear out A. Ever. I don't think any of this is right. Shift it afterwards. Get rid of that. Or it like that. Store it. I don't know why I keep going to 2016. 4016. And it with... Actually, this doesn't need those. That's not a number. That's not the one I wanted to do. Doesn't need those. 0, 1, 1. Turn that off. Yoink. Paste. Right? I mean, I'll keep them as 1. Okay, so for each of these, it loads that, ands it, so it gets only the bottom bit, then shifts it off, so we don't have to worry about it next. All right, yeah, so this, I don't know, this was just garbage, what that was doing. Okay, let's try that again. Nope. What the hell? Come on. Right test. Okay. Is this doing what I expected to, what I think it's doing? Reset the address. Okay. Get past the first one. Sure. Sure, why not? All right, load up that. 30. Okay. Okay, so write byte. Store it there. Rotate. Rotate left. went the wrong fucking direction again. Wait. This isn't the new code. I didn't fucking compile, did I? Or assemble. I didn't fucking build it. I didn't fucking build it. I'll have to compile something. Sheesh. And it. Shift it. There we go. Or it. Load it. And it. Shift it. Or it. It's like the Daft Punk song. Read it, write it. Zip it and zip it. 3, and it was 1. Oh, got a 1. Okay. Okay. There we go. That's more of what I'm expecting. Hit B to reset, read. Oh my god, that may have actually worked. Holy shit. Okay, reset. Over here, make... That's not how you spell make. Make send. Thank you. Turbo file. Read. Nothing. Reset. Start. Ah! Holy shit! Oh my god! Okay. Power off. Unplug. Battery power is still on. You can't see that, but battery power is still on. Plug it back in. Power. Start. Turbo file. Read. Let's go! Okay. Fucking beautiful. Fucking beautiful. Okay. Bank 2. Reset, read. Reset, bank 1. Reset, read. Ho ho! Let's go! Ha ha! Okay. Write protect on. Bank 4. Read. Reset. Try and write. Reset, read. Haha, okay. Write protect off. Reset, write. Read, reset, read. Oh, let's go! Okay, we figured it out! Fuck yeah, alright. Okay. So, that means we're going to do that. What was that? Yeah. Freeze input. Okay, so what else reads controllers? Standard controllers, turbo. Feet. Okay. Okay. So, let's have a look at shit, what was it? That's the family trainer mat, I think. How to feet read. Exactly. Input devices. strobe. I don't have to worry about it. Okay, so I can, in theory, just set these guys like that. Safer way to do it would be have a variable that reads controller code, reads the controller code, or the controller code reads for which bits is set. That would be safer, yeah. I'm not gonna worry about it right yet, though. Ah! Not my controller. Make sure this still works. Let's go! I love that. Okay. All right. That's okay. Okay. Oh, let's finish fixing sleeping. This there. Get rid of that. And hold up. Why does the IRQ use sleeping as well? What? Daisy use sleeping. Oh my god. What? Also, I need to be up here. How did that not completely break, honestly? So we're going to fix that one first. No. Yes. Not yet. No, no, no. Fix. Wait for NMI and wait for IRQ. Use sleeping IRQ with wait for IRQ instead of using the NMI's sleeping variable. Set the sleeping variables before the wait loop for both NMI and IRQ weights. I mean, it shouldn't. I think the wait for IRQ was titler stuff. And that one just didn't break because, I mean, IRQ happened before the NMI, so... I don't know, something like that. So, probably. I'll have to break out my titler to double check that. But, I mean, it should be fine. Probably. Okay. What did I change here? So for the Mahjong stuff, I thought my code was broken or that I didn't implement everything because the controller was broken. Oh, no. Okay, I actually want that fixed. Yeah. That's that's putting the buffer index, setting the buffer index after the buffer's written. So in case NMI happens first, you're not writing an incomplete buffer. Add. Mahjong. Do I do any of those? Hang on. No, I don't do it like that. Okay. Commit. Tweak Mahjong buffer update code. Write the buffer index after the buffer has been filled with data. All right, so now turbo file. Oh, well, yeah, I'll put that in with the draw text. I have to put the draw text stuff in with the turbo file. Yeah. Add the turbo file. This menu option will read contents of the turbo file in 16 byte increments and display the hex values for each group of 16 bytes. There is also a write test. Pressing start will write a all right, static values, right? Static values. The ASCII values for 0, 1, 2, 3, 4, 5, 6, 7 to the first eight plus 1 bytes of memory. Yeah. I guess they had to call it turbo to hide the fact that it's really not. Right? It doesn't exactly have a lot of wires for communication, and there's no problems with using the read wires the controllers do. Don't other things like send back 4 bits? Like, doesn't the family trainer do that? No. Okay. Well, it's 2 bits. That would have made it a little nicer, I think. Not as bad. No, fuck. Wait a minute. Wait. Hold up. What is this? Wait. Family trainer. Family trainer. Yeah, okay, never mind. This one does 4. So yeah, that could have like cut down the amount of reads by like an order of magnitude. Right? 4 times less fucking reads per byte. For writing? Alright, well, writing, whatever. But reading the stuff out, I don't know. 4 times the cost of the serial round trip? Man, I don't know. Is it an SRAM chip? I don't even know. I probably should have taken fucking pictures when I had this thing open. I don't like opening this thing because the plastic is disgusting. It's terrible. And I feel like I won't be able to get it back together again. And that's a problem because these switches... Hang on, let me actually get the better pictures that I said I was going to get. Come on. So these switches, right, are just little bits of plastic that have like a metal like spring tab, and they connect directly to, they rest directly on the circuit board. So without the case, those switches are just not connected to fucking anything at all. So the case needs to be like securely together for those switches to work. Which is horrible. This is the one I have coming in the mail, by the way. This one here. Also, lining up that fucking light again after you have it apart is a bitch. Gonna be annoying for... I mean, sure. You know how bad I am at math, Jamega, all right? Sheesh. Yeah, but this other one I've got coming in isn't nearly as bad in the battery bay. And I also have the first version of this thing coming in the mail as well. This guy. This guy's coming in the mail as well. Two binary orders, man. See, there you go. That too, especially with having to combine serial write with half parallel reads. Yeah. Yeah, it's still annoying as hell to read it serially. Oh, God. Oh, man. Like, imagine trying to, like, implement a file system on top of this. Right? So when I first found out about this thing, you know, I saw... Where is it? I saw the list of games. Like, wow, that's not many games that support essentially what's a memory card. And then I look at how it's you know, actually used, and I go, oh, that's why. No one uses it because it's a bitch and a half to use. I see. I think the worst part is the combined read and write where you can't read without writing. Yes, I don't like that at all. At all. God, yeah. Yeah, because otherwise you just clobber everything. An order of magnitude of a bitch and a half. Exactly. So you get it. Oh, look, it's a shift register. Yeah. That's all it is. It's just a shift register. That's just like reading a controller, right? Right, guys? Game World stream from it? Huh? Oh, God. Oh, my God. That'd be horrible. But, I mean, it'd be a funny feature to have to, like, you know, back up save data to the turbo file. I hate that I had that thought, because now I kind of want to do that. Fuck! Back up work RAM to the turbo file. Oh, my God. Do I want to do that? Do it, GIF. Yeah. Because if I put that into like a self-contained routine, I'm gonna be tempted to put that in everything that I have a fucking save RAM with. Yeah, 8K in size. Yep. And this one here has 4 banks of that, right? This switch up top selects the bank number. I mean, the first one doesn't have this, but yeah, I think a few of the games, most of the games will, that's the wrong. Most of the games will, what's it? Play nice with other files with its own format. But then there's like 1 or 2 that just say fuck everything else and write to the whole thing or the first file or what have you, right? Yeah, memory setup and file format. Yeah. The first byte of memory, offset 0H, is unused, potentially out of fear that certain games with controller access might disrupt it. Yeah. So a dummy byte is used to skip it after resetting the address. All the rest of the space, 1F at the end, is used to store save data, with files being attached directly after each other. Invalid file IDs indicate the start of free memory. You know what? I might want to implement this instead of just raw file read or raw byte reads. I might want that as well. I might want to like read files. Right? Yeah. The majority of turbo file games utilize this format for save files. ID, AB. Okay. File size, including title and checksum. Title, data, checksum. Check all n bytes in data portion added together. Okay. The exception to this, Castle Excellent, uses a unique file format shown here. 1. Don't care. Should be 0. Fixed at offset 1. Okay. ID. 55. Fixed at offset 2 to 3. 508 bytes of data. Encode. Brunton. All right. Followed by some unused bytes. The game mode also forgoes a file name and utilizes a hardcode memory offset of 511 bytes. Now, due to the hard-coded memory offset, Castle Excellent will destroy any other file that is located at the same address. Some later games for both Famicom and Super Famicom, including the Fleet Commander, are able to properly manage the Castle Excellent save file. Oh, there's a dumper. Look at that. Of course. I should not be surprised. From last month. Oh, damn. Okay, this is new. Fuck, we're gonna break your saves. Yeah. Spirit, how you doing? How do I manage to stay focused for long periods of time? See, that's the secret. I don't. half of my streams, most of my streams, for half the stream, I am distracted. That's the secret, is I don't stay focused. I apologize if you were looking for a helpful answer, but yeah. Cast Selection was one of, if not the first game using it. It's probably made before that file format was defined. That could be it too, yeah. Does not take any responsibility for data loss. Yeah. Enabling the right protection is recommended to prevent accidental data loss. Yes. Reels remove my attention span. Oh, well. Keep grabbing my phone every 2 minutes. No! Stop it! Hide it. Hide the phone. Alright, yeah, FDS key, okay. Physical disc will work, but dumping capabilities may be limited by right protection measures. Okay, yeah. Menu will appear. Oh, so that's for, yep, recommended for drive emulators or drives with web protect enabled. And slow. Oh, right, they time. Yep. Nice. I'm gonna start that. The Profile Twin. The Super Famicom variant. I haven't done any Super Famicom stuff yet. Honestly, the Super Famicom stuff has probably been pushed a little bit further down the road. Because I got this working the other day. I replaced the belts in this. Because the belts are in horrendous shape. I mean, you can kind of see like the pinch at the end of that, right? You can see that pinch, right? The sharp corner in there. Yeah, it ain't supposed to be like that. Also, they're supposed to be black belts. All of them are. And someone just like got some random ass rubber bands, I think, and put it in there, and those were the wrong size, I think. But yeah, so this actually works like really well now. I say as it doesn't keep play held down. So before, like, it couldn't rewind at all, especially newer tapes, especially this tape here, right, with the large amount of the 90 minutes of runtime, right? It couldn't rewind this at all. This one is only what, like 10 minutes, I think, of I'm sorry, 5 minutes of time. You can't even see the tape in there. You can't even see it. But no, it can actually, like, you know, rewind, you know, actually use the good tapes. Yes, the Coco tape drive. It is mono. Mono input, I believe. It's got a mono head on it. Yeah. That is not a stereo tape head. That is a single channel. Yeah. Not stereo, unfortunately. So I cannot use this for any study box stuff. Unfortunately. I could use it if it's just for the data. Which, honestly, I might try. Right? To see if the data will just work. Right? I mean, okay, I won't get the recorded audio. But if I can confirm that the data works for some of this stuff, we can confirm that other steps of the program actually work. You know? The steps of the process, rather. So, I mean, it's still a step in the right direction. Yeah. Well, so it's not about like not needing the audio tracks. More of taking a tape that one of like the English tapes, right, and just throwing out the recorded audio and just writing the data and seeing if I can get that playing, right? Because I haven't been able to do that yet. I haven't been able to successfully get a whole tape played. I got one where it just repeats the first page, right? So it'll show the title screen and just repeat that title screen over and over and over and over again, right? Which is wrong. But with the brand new belts in this, and maybe a clean on the head, and like, are there like tape demagnetizing things? The head demagnetizer, like this shit. That seems AI generator or something. I don't know. Is this really? That's a real thing, isn't it? I don't want to open that up on that on Amazon because talks my location. $20. I think $30 shipped. Have you even thought of a demagnetizer? The only reason I'm thinking of a demagnetizer, the only reason, where was it? It's because it's mentioned in here, in the service manual. So I went and found this, so I knew where the third belt was, because I didn't see the third belt anywhere. Manuals, by the way, used to be fucking amazing. Like, okay, so disassembly instructions in the manual? What? Okay, so it shows me what the belts are. Okay, that's neat. That's pretty cool. Huh? Circuit description? Wait a minute. Fucking... Okay, lube these things. That's... Okay, sure. Yep. Oh, yeah, I think it was it in here? No, it was mentioned somewhere in here, by the way. Mechanical adjustment. Okay, yeah. Auto shut off. Yep. Troubleshooting. Yep. Fucking beautiful. Top view of the PCB. The bottom view of it. All right, neat. Wiring diagram. Okay. Exploded view. The general one. The mechanism exploded view. Electrical part list. What? And then more fucking schematics and diagrams. You don't get this shit anymore. Yeah, really nice and detailed. Like, holy shit. What? Probably because Radio Shack sold all this shit, honestly. That's probably why it's so nice. Because they sold everything inside it. But yeah, you don't get this anymore. This just doesn't happen anymore. Yeah. Custom manufactured for Radio Shack. A division of Tandy Corporation. But yeah, somewhere in here it mentions using a demagnetizer. Standard maintenance, number 9. 5, 6, 7, 8, 9. Demagnetization. Do not use magnetized tools near the head, since they can magnetize the head. Fair. With normal use, the head will retain small amounts of residual magnetism. This results in increased noise and loss of high-frequency response. A standard tape head demagnetizer, or use a standard tape head demagnetizer to demagnetize the head. So, yeah. Charles Tandy. Of course Tandy is his name. Of course. Using vertical integration. even certified service people, probably under NDA, almost certainly under NDA. Yeah. Yeah. But yeah, maybe I'll grab a demagnetizer and fuck. I mean, I'll probably use that in my other ones too, because why not? You know. I'm pointing to it. It's behind the curtain. But the other one I have, the one that's larger than this, the big black one, that I tried to use for study box stuff at one point. That one, the quality on that one is garbage. I actually need to open that up, and inspect the belt. I'm kind of tempted to do that right now, though. Give me a minute. Hang on. Hang on. Where is it? Ow. Found it. Found it. Found it. Do I have my screwdrivers over here still? I need to get those too. Hang on. Okay. At some point along the line, he died, and his executive team went on. They had thought he had planned. They did all of it, and ran out of ideas. And defaulted to MBA mode, which includes let's sell off business units. Oh no. Oh, that's unfortunate. That is very unfortunate. Founded in 1990, 107 years ago. Hinkley Tandy Leather. Leather? Wow. Yo, let's move into a completely different industry than where we started. I mean, to be fair, like 107 years ago, the personal computer industry didn't exist yet. So, I mean, it had to be populated by somebody, right? I don't have a tape in here, right? No. Okay, so this is the other old one that I've got, right? And I've never actually opened this one up. So I want to have a look at how bad the belts are. I did actually buy a pack of shitty belts from Amazon as well, just for shits and giggles. I might see if I can try some of those in one of the study boxes to see if I can get one of those working. Maybe, I don't know. There's one, because there's one of them that I have that like has grinding noises, I think, right? I might see if I can try that one. I don't know. Samsung started out as a general trade company. LG is a cosmetics company. No cans of paper mill. Yeah. All right. Two little ones. What is this, like C batteries? Yeah, 4 C batteries this bastard takes. Or you could just plug it directly into the wall, which I opt to do. All right. Let's... Ew. Oh, those are flat belts. Okay. 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 Are they any good? I don't think so. That feels a little loose, honestly, if I do say so myself. How many are there? Is that one? Just one belt? I think it might just be one belt. Let's take off this other circuit board. I know you can't see anything I'm doing. I realize this. Motorola? What? Tandy renamed to Motorola? Wow, this is a lot simpler to take apart, and a lot more space in this one. Yeah, that belt is kind of loose. Honestly, compared to the belts I just put in this other thing, that's terrible. And it's filled with plastic. That one's filled with metal. So this one's cheap, obviously. Maybe my next Amazon order, I'll get the flat belts. I'll get a bunch of flat belts and see if I can replace that. For shits and giggles. Giggles and shits. Yeah. The circuitry in this, like for power, is horrifyingly simple. It just has like a transformer. A little transformer from mains. God. And is that... What the fuck? Oh, okay. Well done. Okay, it doesn't hook the battery up to mains. Okay. All right. I think it actually disconnects the battery when mains is plugged in. Hopefully. Probably. I'll test that sometime maybe. Galvin Manufacturing Corporation. Oh. Big batteries racing? Yeah. Oh. OPs is quite simple, like a transformer, a diode bridge, and a capacitor. Simple. Lighter GPUs to make? Yeah, more power efficient, certainly. Oh. Come on, get in there. This can't even be that old, can it? How old is this? Does this have a date on it? Panasonic! Let's see a date. Let me get this thing back together. Pook, how you doing? Welcome. Hello. How's your week? There we go. And then no down here. Come on. There it goes. Yeah, like I said, I got I got belts specifically for that Tandy tape drive, right? That work absolutely beautifully. And I found belts, a pack of belts on Amazon. And I figured, oh, those are gonna be the cheapest, most terrible belts I can find. Let's get a pack. Why not? Woo! So I might try some of those in, like I said, in the study box to see if that helps at all. Because I have a feeling that that's like one of the issues. They're thicker than the study box ones. So the study box ones are what, 0.8 millimeters across, and the ones I have are like 1.1 maybe millimeters. So they're a little thicker, but I'm curious if it'll work anyway, you know, because it might. Who knows? I don't know. I need to put this somewhere. I need a better place than the floor for a lot of shit. Everything behind the curtains on the floor. I need like shelving. Honestly, I need to go get some shelving. Transformer puts voltage in the right level, and diode bridge rectifies, so the capacitor smooths, and the whole thing is dependent on the input voltage. Yeah. Yeah. Oh, I forgot the cover. Ugh. Okay, so, anyway, I didn't commit yet. Why? There it goes. Actually, I don't actually know if the first byte is read only. It's probably best to ignore it though, you know, just in case. It's probably not read only. I don't think I want to test that though. I don't think I care to test it. Oops. There that goes. So I would like to get one of these files, right? I think it's just normally unused, not read-only, required to be 0. Yeah, that would make more sense because the circuitry to make it read-only, I think would be more than this thing's worth. Let me rephrase that. The build quality of this is ungodly cheap. I don't think they would have spent the money on that. Switch mode power supply still has a much smaller transformer coil, but the feedback path sets the output voltage so it doesn't need to draw nearly as much power. It can handle a wide range of inputs. There you go. All right. Fleet Commander. Do I have this one? Yes. Why did that take so long? Wait, okay, it's got turbofile on the thing. Okay, so if I unplug that, essentially, none, and reset. No, okay, it still puts that on there. Interesting. Okay, so we're gonna, nope, not that. We're gonna, yes, input, turbofile. Okay. Okay. What does this do? Start. What the hell did that do? Absolutely nothing. Okay. Tried to find one. Yes. Start. Oh, God. End. So this is like Battleship, essentially, I think, right? It's doing a lot of shit. I don't know what I was doing, but I was doing a lot of something. Okay, that's all I wanted. Okay. Oh my god, this is taking forever. How big? Oh my god. Okay. Pause. How dare? There's nothing there. Do I have to like close first or something like that? Yes. Oh my god. But okay. We have some data. Cool. So we're gonna copy that to key test. Turbo file. Read. Look at all them chickens. Okay. Okay, now we have a file to read. Okay, cool. Okay, so. Okay, Castle Excellent wasn't the one I did. Okay, so ID. Let's actually go back over to here real quick. Less, not less. Less than that. There it goes. Okay. AB. Yep. File size 2 bytes. 025F. $607. So that does bring it down to here somewhere, I think, right? Because it's 4 bytes past this. Yeah, okay. Yeah, so that's the whole, that's right there's all the data right there. Okay. Okay. File size 16 bytes 16 bytes title in ASCII. Fleet Commander. Is that okay? The one there is nothing. Oh no, it's a space and then Fleet Commander. No, I'm gonna nope. The space is in the middle. Data portion and then a checksum. Terminated by 0 or 1. Okay, so that's the terminus. All right. All right, and then rest of his data. Checksum. Okay. So, yeah, let's have a routine that looks for a file, right? So we'll look for AB. 3 code warrior, how you doing? Yeah, we'll look for the AB. That's an identifier for a file format, or for a file. Okay. Go to that one. Rotate. I shouldn't have had that in there, but oh well. Okay. Read file. I don't have well, I've got a bunch of RAM somewhere that I'm not using, right? Probably. Memory viewer. Again, look at all that RAM I'm not using. Oh my god. Push seg segment PSS pop seg, like that. And dot res 16. Okay. Read file. Okay. So let's JSR to reset address. Like, how you doing? Welcome to that. Then we're going to JSR to read byte for nothing. JSR read byte store a temp x JSR read byte store that into temp y. Actually, no, I don't need to do that. Compare load a temp x. Compare that. Severain? Severain? Severian? I know I'm saying it wrong. Hello, how you doing? Welcome. Compare that to compare it to A. You can go on that. Okay. Welcome. How you doing? Branch equal RTS. JSR. Yoink. Paste. B. Haven't written 65 in so long. I enjoy it. I've been writing it for 8 years now, I think. Give or take. This is all in the context of the Famicom or the NES. All right, so we found a file. Cool. So now we're going to JSR read byte, load a temp x, store that into address pointer +0. Going to paste address pointer +1. Commodore 64. Okay, nice. Nice. I haven't done any Commodore work, mainly because I don't have one. What I will start doing soon, however, is TRS-80 stuff, because I got one of those. I recently acquired this, and yesterday, I think, was it yesterday? Day before? Yesterday, I got new belts for this guy, so it works beautifully. So I can load and store shit from tape on this guy. I do have a ROM card, essentially. I forget what it's called, but a ROM card coming in for that as well. Yeah, that is 6809 assembly, so I will probably be doing some of that soonish. I've got some ideas of what I want to do. This was not Z80. This is a TRS-80 Coco, the color computer. Color computer 2, which is 6809. Yes. Yeah, the original TRS-80 was the Z80, but this one's not. Because I don't know why they did that, honestly. I don't know if that was a smart idea by them, but yeah. Like, did that guy ever dump that ROM? Nope. Never heard from him. Never fucking heard from him. Which is so disappointing. Yeah, right? Yeah, they didn't even respond to me, the bastard. But Z80 was a fantastic choice at the time. Again, I haven't done Z80 either. Guy officially sucks. Maybe he doesn't have DMs on or something. I don't know. Okay, so load Y. Load X. Yeah, load X. Load X 16. No, because that's ASCII. So load X 0. So I'll just put it in the beginning. It's fine. It's fine. What could possibly go wrong? Loop. JSR read byte. Load. I don't like having to do that. Where's the other read? I'll keep that shit there for now. That's fine. Yeah. Yeah, it makes more sense to load it anyway, so I'm just gonna fucking load it. It's fine. Load it. Store that into what do I call it? Buffer data. Buffer data. Unless if compare that to 0, or I can just branch equal to done. Compare it to 1, done. Otherwise, that jump to loop decrement X. No. Increment X, compare X to 16. Branch not equal to loop. Load A. 0. Store that into buffer data at X. Am I familiar with the 65A16? Vaguely. I haven't done anything with it. I know that's the Super NES, the SNES, Super Famicom, whatever. I haven't done anything with that yet. That is one of the systems I do want to eventually look at. But I'm not there yet. I do have a ROM card for it, so I can put ROMs on hardware. But yeah, I need more. Oh, I have too many things to do and not enough time to do them. You know. Cipher 2 is what? Three registers. Yeah, 3. You know, usable ones. Must be used to have so many that programmers don't even know how to use them properly, and that's why L3 caches performs reliant. Modern programmers writing for anything modern don't handwrite assembly. So no, the performance hits that we have today is because you're loading fucking Electron for your Notes app or some shit, right? You're loading an entire operating system, a web browser, for your fucking Notes app or whatever the hell, right? That's why shit's garbage. 3 usable registers, right? Sure, there's technically more, but you're not going to be using those for actual data anywhere, you know? All right. So right there, And then we're just gonna store X actually into buffer index, maybe? Load up low byte of, where do we want to put this? We're just gonna throw this on the screen somewhere. We'll put this down here. 2205. 2205. Buffer adder low. Oh no. That's not going to work the way I think it will, is it? Buffer adder high. Will it? Oh god, the unrolled loop is stupid as hell. I hate that. The 653 can be a little easier to handle if you consider a zero page to be a set of 256 indexable registers. It's shown that 16 registers still has a significant overhead compared to providing 32. More than that seems to be the current limit. So this buffer that I have, I built that specifically for for the keyboard output, which was every fucking byte, every tile at a different address. Oh god. So we're gonna do this. This is gonna be so disgusting and stupid. Yes, the family keyboard. Yes, I get behind my screen, I think somewhere. All right. So for all these, store that there. Don't increment X yet though, because we're gonna load address pointer 2 plus 0. Store that into buffer adder low. Yoink paste plus 1 adder high. At X, at X, at X. Then we're going to increment X. But before that, we're going to increment address pointer 2 plus 0. Branch carry clear over the other increment for plus 1. And then increment X. Yeah. So now... Now I can use the buffer index, the buffer thing the way I... Where the hell else do I actually use this buffer data thing? Do I do it correctly for the other shit that I do? I don't think I do. Oh, no. Oh. Let's do that instead, actually. We're going to use the draw text macro. or not macro, but the draw text routine. So nope, not doing that. JSR wait for NMI. Mac draw text buffer data at 2205. Yeah. Data to ASCII. And then what a address pointer plus 0, store that into buffer data, buffer underscore data plus 0, going paste 1 1, load a 0, store that into buffer data plus 2, Mac draw text buffer data, not gonna be there, it's gonna be 21E5 E5, but after we wait for NMI. Make. Okay. Done, undefined. Really? 336. That is correct. Done is, in fact, undefined. All right. Miracle keyboard, which I've yet to reverse engineer. Then the Miracle Piano teaching system keyboard. Yep. So I don't have reversed, but it's a synchronously clocked MIDI data setup. I think that one goes directly to the cartridge, doesn't it? Or does that plug into the front of the NES into a controller port? How many was there to chanting at 8 inputs to the whole 64 piano keyboard? Yeah. Miracle Piano. This guy here. Yeah. Is a 49 key synthesizer, MIDI synthesizer built by Antex on behalf of, yeah, sure, for using RS-232 serial and synchronous clocked bit protocol as MIDI transport. As part of the Miracle Piano teaching system, which had software implementations for at least NES, Genesis, PC, and Macintosh. The NES implementation of the software expects the, quote, Miracle cable, I seem to remember something about that now, to be connected to controller port 1 and a standard controller to port 2. Keyboard interface is bidirectional, appears to be via clocked shift registers. Ew. Data is comprised of octets sent and received, most significant bit first. Bit first. Data is pulled from the keyboard, raising out 0 for 12 CPU cycles. Oh my god. Lowering it and clocking a bit. Oh. May need to burn 6 cycles, about that, before clocking the next bit in. If the bit is set, there's an additional 8 inverted bits to clock. What? That is atrocious. Oh my god. 36 mini keys. Oh, okay. Multiple on the NES side or the peripheral side? Peripheral. Oh. You can also make a new buffer loop and make that indirect jump and NMI the jump to it. And enter the back to the NMI done. That's true too, yeah. No. Other multiplexers on the NES. Oh, yeah, peripheral side. Shift registers for serial interface on the peripheral side. Yeah. Or learning that my parser will probably consume tokens 10 times faster than Alexa can produce them. Yeah, well, string parsing is a bitch. String processing, rather, is a bitch, you know? MIDI Rompler. There's a microcontroller on the keyboard. Right. Music keyboards are usually 12 N+1 keys. There's the number of full octaves plus an additional note. All right. I don't play piano, so I wouldn't know. Wouldn't have known. I do want one of these, by the way, but I don't want one enough to go looking for one, because that means I'd have to spend money on it. And honestly, I haven't. my NES is behind the curtain somewhere. It's not plugged in and hasn't been turned on in forever. And doing a hardware dev on the NES is to store one. Yeah, doing hardware verification and dev on the NES is more difficult, more involved than Famicom, because with the Famicom, I mean, you saw it earlier. Let me hit reset. To get my ROM onto hardware, all I have to do is type make send, and that sends it to the hardware, because I've got a wire. This one. I've got a wire that's going to the cartridge right on top of it. I don't want to move it too much because it will disconnect something. Did it? Oh, beautiful. Still works. Cool. But for the other ROM card that I have for the NES, I don't have that. It doesn't have a USB port, so I can't plug it into my computer. So I have to physically remove the SD card every time I want to get a ROM on the thing, and the cycle for that is more than I want to deal with, honestly. I've got enough full-size basins. Can't have enough, but I don't use the ones I have that I have enough of. That I have enough either. Yeah. I feel that one. Yeah. Not handling anything special in my lecture, just as confusable detection, optimal Unicode normalization. Oh. I suppose I could get a top-loader Famicom for that, but I don't want to have to do that shit, even with the top-loader Famicom, because that one used NES controllers. Use the ports for that, right? No. Okay, does this do what I expected to do? Control-Shift-R. Okay, so it has all that stuff on there. It's seeing it. I'm not actually calling the code. Okay, so let's do that first. We're actually gonna put that right above that. So read let's JSR read file. I didn't mean to send it, actually. Yeah, it timed out because it's in the ROM right now. Holy shit! Okay, cool. The address didn't work, so that's cool. Did I not, like... I didn't do the ASCII bit. Adder to ASCII. Address pointer 3. That actually uses the buffer address. Why? Low, low, low. Oh, it just uses that buffer as a buffer. That's it. Oh my god. Okay. So we're gonna get rid of this, like that. Put this into address pointer 3. JSR adder to ASCII. This is gonna be buffer data. That's buffer adder low. Okay. There it is. 025F. That's the size. Right? Yeah. Yeah. A toasterify it. Oh my god. So the Nest controller has a shift register that the Nest code reads. Yes. So adding bits for more keys is pretty easy. Just chaining the shift registers and having the code read more bits. Yeah. Yeah, that's how the trackball works, right? It's got a standard controller on it. Was it Hori track, right? This thing. So it has a standard controller as well as a trackball. So it reads as a standard expansion controller, but then if you just keep reading, it gives you the data for the trackball. Center Point, how you doing? Welcome. It has been a minute. How you been? So can't do that. Also A5 shift 5. Nope, you can't. It's you do it again and again and again and again. Hori is that old. Well, good. I've been doing all right. I'm doing okay. All right, so that's good. So let me reset that. Over to here. Make send. Send it over there. And this shouldn't write anything. It doesn't. Good. Because nothing's there. Okay. Cool. I'm not sure how I would get that onto it, though. I'd have to, like, build that data into the ROM. Oh, that's just... I mean, I could. That'd be horrible, but I could do that. To get that... all that data on hardware. I don't know if I want to do that tonight, though. Yeah, I do kind of... I do want to flesh out, I think, the file stuff. Yeah. I might make a library for that. Or set of routines or what have you. I don't know. How much space am I using? I wrote bin backwards. Oh my god. Bin key test map. Alright, I'm not using all that much of it. Yeah, start at 8 and at 9. That goes all the way up to fucking C1000, and I'm not using like most of that. Right. So there's the code. And all its unrolled glory for the NMI. And then all that unused space. And then a mirror of all the code. So I could put that in there. I don't want to do that though. Building around with the data is probably the easiest way. It's going to be the easiest way. It's not like having data input via controllers, or maybe that ROM card can do something weird, but that's probably worse. Yeah. I don't know. This has a limited amount of internal ROM for games. And then some games that got on that with a battery and a ROM shifter or whatever. Kind of. You're confusing a few different things. The 6502 has a 16-bit address, right? So it can only address 65,000 bytes. The NES reserves half of that space for the cartridge, roughly. It does a little bit more than that, but most games it's half. So if that game wants to use more than the 32K, it needs to use a mapper to swap out what is visible in that 32K. Could you make a modern card like 10 gig of ROM in it? That's what fucking the ROM card is, essentially. Kind of. with more steps. Yeah, the NES has no internal ROM, right? And cards can do anything they want there with enough custom mapper hardware. You can access however much ROM that you want. Yes, I mean that's how the ROM card works, right? It's pulling some bullshit, and yeah, I mean the card in there is like a 2 gigs, I think. It's a smaller card. Wait, do you have one? You have one. I thought you didn't have one of these things. What? There's not a lot in that. Wow. Okay. Yeah. One chip, bunch of diodes, buttload of diodes. Oh my god. Diodes and some resistors. And then the connection to something. Oh, and so many. Why are the springs colored? What? Oh, I know this. There are different windings too. Okay. The rollover, yeah, almost certainly for the rollovers. Yep. The Miracle Piano keyboard is the one I don't have. Ah, okay. This is the. Oh, okay. Okay, I see. I get you. Gotcha. It's a very bare bones keyboard. It's just a few keys, nothing else. The Don't knock the car. I got one of those too. Different pattern, obviously, but I mean it's underneath the green screen right now, and it's honestly needs to be cleaned. But I have a bunch of other shit on top of it right now. Yeah, I really need to clean my apartment up. I ordered too much shit off the internet, so I've got so many like empty boxes in the other room that I just haven't taken out yet. And behind this screen is so much fucking clutter of shit that I've got that's like Famicom related and audio related, and the scanner's back there, and random wires and shit. So much crap behind that screen. Was doing that shifting stuff with the carts the first Nintendo allowed, or is it like no? So Nintendo was aware that the Famicom hardware would get outdated very quickly, and like price for chips and shit would come down, right? For RAM, right? Like they knew that was going to happen. So they accounted for that and exposed a lot of stuff to the cartridge, right? And didn't really get in the way of anything that the cartridge might want to do, right? So they kind of like left it more undefined than anything else, right? But yeah, the one time they had foresight. And they even have their own branded mappers. The MMC mappers are theirs, right? Get rid of that. Go away. I said go away. Ignore. What? Reload. Fucking go away. God damn. Yeah. Nintendo has a bunch of their own mappers. Yeah. Official or approved. Yeah. Yep. Why is that so dark? What the fuck? Okay. Nintendo made a few. Why was that a redirect? Oh, okay. It's different. Different revision. Got it. Got it. Whew. Ads over? Welcome back. But yeah, so Nintendo had a bunch of them, right? Zero isn't technically a mapper because that's just the mapperless board, right? But yeah, they had a bunch. Welcome back. Yeah, these are the MMCs. 1.3, I think this is. No, UX ROM. Okay. This one's no, that's CN ROM. Okay. There's MMC3. Is there an MMC2? Is that a thing? See if it is a thing, yes. ASM members on PROM and PO-ROM game boards. Mapper 9. Okay. And what about MC4? What was it? Yeah, just punch out, I guess, right? What does this one do? RAM bank, play choice version only. Okay. 8K switchable ROM bank. Oh, that's a... All right. 3 8K PRG ROM banks fixed to the last 3 banks. What the hell? That's a weird way to split that. 2 4K switchable CHR banks and another 2. That's a weird split for that. Yeah. The 2 4K APU banks each have 2 4K banks, which can be switched during rendering by using the special tiles. Oh, right. Specifically for punch out, right? Yeah. Like the AK that goes there. It's like the 4K ROM bank that goes there. Used when latch 0 equals FD. FE. Ugh. The main interest of MC2 and 4. What is this one used? Similar to Mapper. It's a similar Mapper with AK. Slightly different behavior in auto switching. It's on a lower pattern table. This page only explains the differences for MC2's full details. See MC2 for the full details. Okay. This one's got RAM, 16K of program ROM. That's more expected. And then another 16K fixed. That's more expected. Okay. Now, much out they were used the transition between audience and ring and opponent tiles. In Fire Emblem, they were used to transition between map and character portrait tiles. Interesting. Now switching to they allow switching to pairs of 4K character ROM banks at the same time, automatically alternating between banks within one pair during rendering. When the CPU reads from specific tiles, FD or FE, in the pattern tables, the MC2 or 4 sets a latch that switches between two different 4K banks. This allows the tile limit to increase from 256 to 512 with bank splits, without involving the CPU or an IRQ. CPU reads 0FD8, latch 0 is set for FD. For subsequent reads, CPU reads 0FE8, latch 0. Okay. Latch 0 responds to one address, but latch 1 responds to a range of addresses. What? Wait. The bottom, the top table, first table, only switches in the top row of the obey tile. Oh, and the other one switches on every row of the obey tile. That's interesting. Interesting. With this mapper, the first pattern table is intended to use with sprites in the bottom for background. Backgrounds require to switch on every row because sprites aren't constrained to an 8x8 grid. Okay. Tricking only on the first row allows switching sprites to be placed closer together if needed. Okay. This nuance is absent in the MC4, where both pattern table switches from the entire tiles in a symmetrical fashion. Note that the latch is updated after either pattern table byte is fetched, so switching tiles FD or FE themselves are drawn using the old bank before the latch value is changed. As PV fetches 34 background tiles per scan line, and at most 33 are drawn. If vertical mirroring is used, background switching tiles can be placed past the edge of the screen where they will be unseen. This is because sprite slots still perform fetches with a tile number of FF. Using 8x16 sprites will result in PPU 1000 to that. Unexpected change in the bank number when bank number written to E1000 at the ends of certain scan lines. What the fuck is a shrink dip package? A bunch of them were. Oh, how do I know this? I was a Net Simulator author once upon a time. Yeah. Once upon a time. Shrink dip is dip, but the pin density is about double. Okay. Like surface mount density? Oh, yeah, look at that. Okay. Yeah. Yeah, that is certainly tighter together. All right. Not quite surface mount density or size, but yeah. Interesting. That is nuts, right? I did click on the next one. Yeah, that's the next one. All right. Yeah, they are significantly closer together. My goodness. Also, I don't know how people get clean scans of circuit boards like this. Whenever I try to scan a circuit board, it only focuses on the tips of every fucking lead here. So the board itself is way out of focus. It's sorcery. Yeah, that looks like it's about double. Maybe even a little tighter than double, honestly. I'd guess manual focus control. Dude, is that a thing on these? On scanners? Scanners have a focus control? A wide depth of field? I don't know. Yeah, they do it for the top of it too, don't they? I don't think that's scanned. That might be a picture. The lines aren't straight. No. Anyway, I need to clean up. I need to get to bed. I need to get a snack. So, we're gonna read some of those. So don't go anywhere quite yet. Be carefully aligned, or post rotated photo instead of scan. Well, one of those was a photo. The other one looked like a scan. So, is he? Yeah, we'll go over here anyway. He's doing some stretches or something, but we'll go over here. But yeah, so I'll be back on Sunday, doing I don't know what. I don't know if I want to do more turbo file stuff, because this looks like a pain in the ass to deal with, honestly. But if I don't come up with anything else, I might be just doing that. Maybe. I don't know. I might have a ROM that's just dedicated to turbo file stuff that, like, uses the keyboard to type shit in. I don't know. Guess the cocoa isn't ready yet. I mean, so I have one piece of hardware still that's in the mail. And then, I mean, we might do some planning. I don't know, because I can do some planning and some playing around with BASIC. I suppose I could do that. I have the capture set up. So if I... I think it's that one. Yeah. I got the capture set up the other day. So that works. Syntax error. Yeah. But yeah, so we might do some planning and some discovery, I guess, with that on Sunday. Maybe, I don't know. Depending on how I'm feeling on Sunday. So I have an idea of like the direction I want to go with some of the stuff, but there's still a lot of things I need to figure out about the system itself. Things like, you know, reading how to read the keyboard without going through basic, you know, how to work with the different display modes. Like the mode that it's in right now is just the standard text mode, right? So it's got text mode and it has a bunch of like graphic modes, right? Figuring out how those work. I figure something that I could start with is re-implementing Wasmon on here. Probably starting with an implementation in BASIC, and then going to don't reverse engineer the ROMs. Yeah, well, but yeah, so I'll probably start with a basic implementation, and then move to an assembly implementation. But I think I want to do that all on hardware, right? And only use, you know, my computer over here for like documentation and looking up books and all that kind of shit, right? So I don't know. Maybe we'll see. We'll see. But anyway, we're gonna go. We're gonna go raid. Like I said, thank you for being here. Appreciate it as always. I'll be back Sunday doing, like I said, something. I don't know exactly what. I'll figure it out. I don't know. We'll see. But yeah, you guys have a good night. And yeah. See you next time. Bye-bye.